Good morning, afternoon. This is Mr. Precella, and today we're going to begin our college algebra course discussing square roots. We've already shown you all about the videos. If you want to see what we're doing right now, last semester, how we did it, there's those videos there. And we will start with our first problem. We're discussing something called square roots. This is not an introductory algebra class. I assume you've had some math before. Also, we assume that there's certain things you must know. The multiplication tables. If you do not know the multiplication tables, you are definitely in the wrong class. Last semester, unfortunately, I did have a student who did not know 3 times 5. She kept going back, trying to get books. So she got back to a 5th grade math book and still couldn't do it. Poor thing never made it, through the class. But there's certain things you've got to know. If you don't know 3 times 5, you're in the wrong class. Even a calculator won't help you because, a calculator would help you know you could put 3 times 5 is 15. But if I needed to know what numbers multiply together to give 15, a calculator isn't going to tell you that. Okay? So, we start off with square roots. Oh, wait. I don't want this to be there. Now, let's click and start our first homework problem. Oh gosh, I need to, what makes it bigger? Control Shift, let me see. How do I zoom this? Someone just text, what is it? Control Shift plus, does that do it? No. Maybe just Control, oh wait, that was Control. There. Okay, there, that looks better. Problem number 1 says evaluate the square root. That symbol there, that looks sort of like a check mark, is called a square root symbol. It's also called a radical sign. I'm going to write down this problem number 1, and then we'll discuss how to do it. The square root of 100. Square root of 100. Well, what does this symbol mean? Well, it's asking you, what number can you multiply by itself to get 100? I think we were talking about knowing the multiplication tables a moment ago. Could y'all tell me what number could I multiply by itself to get 100? 10. For most people, your first problem will be one that you don't really need to write down. You just type in the answer. Notice how I clicked in the box, type, and I'll say check, answer. And I got it right, so I'll move on to the next question. By square root, we mean what number can you multiply by itself to get, in this case, square root of 169. Well, that's a little bit bigger number. Let me go ahead and write this down. And we'll discuss it. Square root of 169. They've wiped this computer, so my virtual TI calculator isn't on this computer. Can someone get it for me? But maybe we can do this without a calculator. Can someone tell me what number do you multiply by itself to get 169? I'll give you a hint. It's bigger than 12 because 12 times 12 is 144. 13 times 13 is not on the multiplication table. But if you have a little calculator and you punch it in, does anyone have an idea what 13 times 13 is? Someone with the calculator? Is it 169? Yeah. The square root of 169 is 13. Now, I want to demonstrate something. What do you do if you get a problem wrong? You need to make it 80 on this assignment to go on to the next one. So the correct answer is 13. But let me get it wrong. Let me say if I put a 12 in and check it. Oh, it says, okay, tries to give me a little hint. It says that's incorrect. And it's letting me put in another number and check. Let's suppose I put 5 in and check. No, I still have it wrong. It says try again. At this point down here, it says final check. That means this is the last time I can guess at it. Suppose I put a 51. When I click here, it says, okay, you've guessed at it 3 times. The correct answer is 13. I can either go on to the next problem and have that one wrong, or what should I do? Similar question. Oh yeah, I'm talking too loud with the speaker, I forget. Okay, someone with a calculator, or pull out your phone. This one, 256. What times what will give us 256? What times itself will give 256? 16, that's right. 16 times 16 is 256. Okay, so we were looking at the square root of 256 on a calculator like this, which is a very good calculator for the course, at 83 or 84.
If you have one, I would not go spend $100 on a graphing calculator because you're not going to use any of the graphing features. The calculator we're using is strictly number crunching. Okay?
And why are we using this if we don't need a graphing calculator? You don't need a graphing calculator. This is the one that we can get for free that will show up here. Okay? So to punch in square root of 256, I'll go second square root 256 and 16. That's what I heard someone answer earlier. Remember, I'd messed up on problem 2 and it had a red X. I'm about to check it, and fantastic, my problem number 2 is now right. I got the check mark, and we go on. So there are certain numbers that we refer to as perfect squares. Those are the numbers whose square root is an integer, not a decimal number. If we looked at something like the square root of 24, we get a decimal number. Well, we don't, in algebra generally you do not want decimal numbers. So how do we simplify a square root that's not a perfect square under it? Well, let's write out the perfect squares. What are the perfect squares?
Well, there are infinitely many. Yeah. I'm assuming you mean like the first 15.
Yeah. 2 times 2, 9, 16, 25,
5 squared,
36, 49, 64,
8 squared,
80, 100,
10 squared,
144. 12 times 12, 144. All right. Then 169, and I'll just say dot, dot, dot at that point. Okay?
Label those perfect squares.
Perfect squares. So let's do problem number 3 now. The square root of 24. If you're simplifying a number that isn't a perfect square, the way I prefer to do it, the way I'll do it in class and the way I'm going to show you right now, is to rewrite it as a product. By product, I mean multiplication.
You want the biggest perfect square that divides evenly into 24. The biggest number up here that divides evenly. Remember, dividing evenly means that there's a remainder of what? 0. If it divides evenly into a number, then the remainder is 0. Really, there's only one number up here that divides evenly into 24. What is it? 4.
See, this is what I mean about, you've got to know those multiplication tables. 4 times 6 is 24. Now, I'll simplify the square root of 4.
What's the square root of 4?
2
times.
Leave the square root of 6. Like that.
That's read as 2 square roots of 6, or 2 times the square root of 6, or in olden days we called that 2 on the square root of 6, but no one uses that terminology anymore. You come over to to my lab. This is the first time we're typing in a square root.
Wait, notice there's no symbols yet. But once you click in it, it shows the symbols down at the bottom.
Okay, so I type, you see where it's flashing, I type the 2. And then I need a square root key. This is your toolbar here. The toolbar doesn't appear until you've you've clicked in the blue box. We need a square root. As you move around that toolbar, I see a radical symbol. Notice, can y'all use your bionic eye? Can you see what that says down there?
They know it's a square root.
It's a square root.
It looks like a square root.
Look at this one. There's a little box there above that radical. That's for a cube root or a fourth root, and we will see some of those eventually. But here in this assignment, we're only dealing with square roots. You click the square root hot button, and notice where the cursor is flashing. What am I going to type under here?
6. There. Check it. And go. Problem number.
Any questions there? Okay.
No.
Oh, you keep because there's no perfect square that divides evenly into 6.
Okay.
Okay. The square root of 28 is 28 a perfect square? No, it's not a perfect square. What's the biggest number up here that divides evenly into 26? These problems are better. Remember, everyone's problem is different, when you're doing the homework. So it'd be better if this was something like a...
well, there's going to be so many of them that there'll be...
If it were a bigger number, because here, what's the only number that divides evenly into 28? 4.
So following the colors, I'm going to think of 28 as a green 4. You may not be able to tell that's a green 4, but when you watch the video, you can. Times 7. And what green number am I about to write after this equal sign?
Okay.
Square root of 4 is 2. Square root of 7, you can't reduce it. There's
Notice there's no perfect square up here that divides evenly into 7. The number that's under the radical cannot have another perfect square divisor. 4 doesn't divide evenly into 7. 4 times what gives you 7? 9 times what gives you 7? There can't be another perfect square divisor if the answer is in reduced form. So we go and type in. I'll click here, and once again I have a 2. The square root hot button, and under the radical I type a 7. Okay. Any questions there?
Maybe the next one will have a bigger number. Not a huge number, but a lot of words. What is it?
Simplify the square root.
And notice how it has 2 options. Either you put an answer or it can't be simplified. Let me see. here's what I would do.
What's the largest perfect square that divides evenly into 41?
So what I'm doing in my mind is on the computer right now, the calculator, is just showing my thought process. I'm thinking, does 4 divide evenly into 41? What about 9? What about 16? What about 25? I'm not saying you should have to be dividing like these. This is just my thought process. Is there a perfect square that divides evenly into 41?
No, so
What are we going to do? Can't. Already simplified. Okay? Oh, let me go ahead. Oh, what about number... Oh.
square root of 63. Oh, I don't think
Problem
we need
number
to use
6.
our calculator here with the square root of 63. We can look and tell. What is the biggest perfect square that divides evenly into 63? So you're thinking 9 times 7.
Mm-hmm.
The square root of 9, what are we going to write? 3. And we leave the 7 under the radical. Any questions there?
So 3 square root of 7.
3 square root 7. Check answer. Any questions? Number 7.
Oh, number 7 is a great
And
one.
finally we get a good one.
Square root of 72.
Oh, no, wrong thing there.
And I'm going to use my calculator just to show my thought process. At first glance, looking at these, that's 72 divided by 4. Well, wait, 4 goes into it, but use the biggest one.
72 divided by 9. It goes in. But what's the biggest perfect square that divides evenly into 72? 36. That's correct.
72 divided by 36 would be a 2. So use the biggest perfect square. So we would have the square root of 36 times the square root of 2. By the way, sometimes students tell me, oh, do I have to write all of this? I can get that answer without all of that writing. And I always answer the same way. Your goal and my goal are different. Your goal is to get the answer as quickly as possible without cheating and using photo math or something like that. My goal is to try to show my thought process. Okay? So the square root of 36 is 6. Can't simplify the square root of 2.
And notice, is there a perfect square that divides evenly into 2? No, there's no number up here. If you had tried to use 9 times 8, I'll see people doing that. Switch to this for a moment.
Switch to what?
Switch back to this. Oh, it's already there. What am I thinking? Okay, I'll have people using the square root of 9 times the square root of 8. And they say the square root of 9 is 3 and leave an 8 underneath. That is wrong because there's a number up here, a perfect square that divides evenly into 8. Doesn't 4 divide evenly into 8? So this is not correct because you can reduce that 8 further.
Now, a word of warning. My brother and I both had a teacher in the 8th grade that told us to put this little closing mark at the end of a square root. I got out of that habit. Tim's trying to break the habit. He didn't put it here, but doesn't that look like an 8 with a little 1 floating up there? It's just closing off the square root. Okay? That was a teacher from the 8th grade. But is it clear what he's saying? That's a very good point to make.
You have to use the biggest perfect square when simplifying a square root that's not a perfect square.
Now, had we put this answer so they knew it was right? Oh, okay.
Oh,
So
that'd be
I'll type
funny
the
if it were wrong.
Square root of 2, check it, and move on. Oh, wow, 1,500. Number 8, square root of 1,500.
If y'all got it, what's the largest perfect square that divides evenly into 1,500? It's sort of obvious. I think I heard it. I could hear it. 100. 100 times. Oh, wait. I remember we used to have a colleague that would play the videos. This person would talk through the problems, not write anything, and it was very impressive. They could see it up there, so they were talking through the problems. The students hated it because they're trying to write down what the teacher was saying, but yeah, I'm doing the same thing. The largest perfect square that divides evenly into 1,500 is 100. 100 times 15. And if you're not sure, is there a number up here that will divide evenly into 15? It'd have to be smaller than 15. Does 9 go evenly into 15? Does 4? No, so this has to be it. So we have the square root of 100 becomes a 10. What are we going to do with that square root of 15? Just leave it as it is. Any questions there?
Type it in. There was like, back in the olden days, the back of the book, there were answers, and I remember instead of having a computer, we'd get the problems from the book, I'd work it out on the chalkboard, and then once I was through and had gotten an answer, there would be this.
As everyone turned to the back to check, they had so much fun.
And then they seemed so relieved every time. That's why I'm like, okay, I've got to make sure that we always check them so that y'all will believe I'm actually getting the right answers. Okay?
Also, sometimes I have wondered, how far could I go just making up stuff before students just, called out shenanigans or something and stopped believing me?
Easy or hard? Problem 9.
What do y'all think? Easy or hard? What's the biggest? Is 45 a perfect square? Say no. No, it's not a perfect square. So what's the biggest perfect square that divides evenly into 45? 9. 9 times what? Not 9 times 4, that's 36.
5,
9 times 5. Now can 5 divide, does 5, can you simplify 5 any further? No, 5's a prime number, so you've got the biggest number dividing evenly, 3 square roots of 5. Any questions there? 3 square roots of 5.
Well, there has to be one that gets a bigger number.
Well, the 1,500.
Yeah.
Oh, I like this one.
I want to run and get that calculator.
Run your ball. Okay, here's number 10.
There's a calculator that a student used to use, and at the end of the semester, she gave it to my brother and said, I'll never use this calculator again. I'm through with
math. And it
math.
just had bad memory. She told me it had bad memories. She was a good student. I remember she sat on that front row answering all the questions.
Is that it?
And I was just shocked that she would say that, her math class was going to be bad memories. But I always thought, well, she's really enjoying the class. She's on the ball. And she had no problem telling me.
This is a Casio FX 115 ES Plus. And you might say, well, what's so special about that calculator? Well, on this calculator, if I punch in square root of, if I punch in something like square root of 99.
Well, no, do the one that we just finished. The one that we just did.
Oh.
So they already know the answer. Move that so I can see what it was. Okay.
So you do square root of 45 on that calculator.
Here's this little thing. You're doing the square root of 45. It's not going to give you 3 square roots of 5, is it? It gives you a decimal value. But on that little calculator that...
Casio FX 115 ES. The square root key is right there.
Y'all see?
I said, well, they can't see, but just trust me. And I punch in 45. Ooh. Let's look at what it's about. No, that creates. Well,
I think that makes it a little better. So the square
hit
root of
equal.
45, hit equal. Look at what it gives. Do y'all see that?
Okay. This is a nice little $20 calculator. Does yours do that? Oh, wow. It's a fancier update.
Oh, it's a fancier.
Yeah, this looks a little nicer, that one. Hopefully you're not going to be telling everyone this has nothing but bad memories. It was a good student.
Yeah.
Watch out, I think her name is on here.
I know it. It's on the back. No. Oh, wait a minute. Where is it? I was just looking at it, thinking about it. Oh, that's the wrong one. That's not hers.
Oh, well, still,
We have
anyway,
two
you
of
have
them.
students giving you calculators at the end of the semester. So there. There. But we're not going to use that calculator. But if you wanted to get one like that, that's not considered cheating. If it were, I wouldn't be showing you to do it. Now, what about the square root of 99? We better get this one done.
Here it is.
At this point, sometimes students say, oh, I can do it in the head.
Oh, there's her name right there. That's still, no,
Okay, Tim, stop that. We got to hurry. We're running late. Okay, square root of 99. What perfect square?
divides evenly into 99.
4, 9, 16, 25, 36, 49, 64. Certainly too big.
One of them stands out. One should be obvious. 9
Nine.
times
11.
The square root of 9 becomes.
Yeah, this is black. Square root of 9 is a black 3. And we know we're correct because the 11, no perfect square divides into 11. Okay, so just 3 square root of 11.
3. Okay.
Now we're halfway through with this, and
Now, we didn't even really ask and make a decision. Were we going to take that 10-minute break or keep? And then we're going to go on. Number 11. Oh, square root of 50. No, that was 45. I was about to say, wait a minute, we just did that. But the one we did was 45.
54.
Okay. Square root of 54.
The reason I'm not lifting the page up higher is I'm trying to leave these perfect squares there. So,
That's the largest perfect
perfect
square
square.
that divides evenly into 54.
Start using your calculator, Tim. Punching it in.
What do you think? You think it's got to be under 54?
So just test all every
So, so how about 49? Surely not. That'd be 1 and some remainder. What do y'all think? Y'all know your multiplication tables. I bet someone can tell me. Let's see, wait. 54. What did you say? I think it's gonna. Oh, I was thinking it was 9. 16. No, that has a decimal. I think it's 9. 9 times. That's
6.
right.
So I'm using green. So that's a 9 times 6.
And
I'm
this-
going to
seems
write
like
what
9
green
keeps popping
number.
up. We'll get into the streak where everything's involving a 9. But does that mean it's going to happen in your homework too? Where the next 9, 10, 11 all involve 9s? No, it's just a coincidence.
I remember the semester the student emailed me and said that there was something wrong.
They were getting
They had different numbers. Their number 1 was not square root of 100. And I was like, yes, your number 1 has different numbers. Everything has different numbers. Okay? So sometimes there might.
Yeah, sometimes they might be the same. That happens, occasionally.
But not. I'm not
really.
actually doing the problems I'm doing is not really your homework problems. Your homework problems, that's the advantage of this sort of problem over a paper book. With an old-fashioned book, everyone had the same problems. One person could do it and everyone copy it. But nowadays, you can't do that.
Mm-hmm. Oh, wait, I didn't type in the answer. What was it?
3 square root 6.
Okay. Number 12.
Okay. Finally, something other than just simplifying. This is a multiplication problem. How do we multiply square roots? Okay. It's just multiply and then simplify by factoring. That's what they're calling what we did with this, what we're doing right here. When you write two things as a product, multiplication, that means factoring. So that's why the instructions say multiply.
Yeah, just really just.
So wait, Tim, wait, what was the problem? I didn't write down the problem.
Square root of 2 times the square root of 10.
But first, you have
Write
to
down the
multiply.
problem.
Okay, square root of 2 times the square root of 10. You actually, the new thing here is you've got to multiply these numbers. 2 times 10 is 20. Now, simplify that square root of 20. What perfect square divides evenly into it? 4 times 5. You see, this is like steps that some students are like, well, I don't need to write all of that. Yeah, you don't have to write all this. I'm just trying to show with the colors especially. The blue square root of 4 became a blue 2. The square root of 5 just stays there. And you're about to say something, Tim.
So let's make the rule to multiply square roots. If you have the square root of A, oops, there's that little hook, times the square root of B, you can rewrite that as a single square root by multiplying the things under the radical. The things under the radical are called radicands. Multiply the radicands, A times B. To multiply radicals, you keep the same radical, multiply the numbers underneath them.
And that's what we did right there. Now, I don't remember, did I check that? So y'all can be relieved we got it right. 2 square root of 5. Problem 13.
Oh.
I know that.
Okay.
Oh, just been easy or hard? Okay. Square root of 2 times the square root of 2.
Okay, switch
square
it
root of 4,
over.
that's right, okay. Wait, lower, Tim.
Lower, you're right. Okay. So, we're multiplying square roots, so we keep the square root. 2 times 2 is, and the square root of 4 is, and that gives us a rule involving multiplication of square roots. The square root of anything times the square root of anything.
Same thing under both square roots. Did
Real-
y'all complete this rule? If these two numbers are the same,
The square root times itself. So the radical just disappears and leaves you the thing under the radical. Here's something we could do. The square root of A times itself, I could write that as the square root of A squared, but either way, we're just left with A.
what you've just done, Tim, is write two rules. There's one.
The square root of A times the square root of A equals just A. Or, if we have a square root being squared, the square undoes the square root, leaving you just the thing under the radical. And that will be important.
This rule we're going to use off and on all semester long. I usually put a red star by it, but for some reason I don't have any red ink.
How about a pink star?
Okay.
We'll put a pink star.
Yeah.
Okay.
Important rule.
Did you type in that answer for number 13?
2.
Okay.
Mm-hmm.
Number 14.
There's 20 of these problems, unless you're wondering. The square root of 3 times the square root of 15. The square root of 3 times the square root... Oh, I'm still writing those little hooks there. Is that bothering anyone, the way I close the square roots? It bothers me every time I see it. I think of 8th grade Mrs. McGowan. Okay, so it's the square root. We keep the square root. And 3 times 15, I agree, that's 45. Is 45 a perfect square? No. 40. Okay, remember, I think we've already simplified it down here somewhere.
Oh, wow.
But number 9, okay? 9 goes evenly into 45, so you think of it as, okay, wait, square root of 9 times the square root of 5, and the square root of 9 we write as 3, and what do we do with that square root of 5? Just keep it, stick it on there. 3 square root of 5. Okay. 3. I know, I don't like it either. You cut the page, can you tell? Now, by the way, at any time, if you decide, oh, I once had a student tell me, oh, wow, this isn't enough problems. In high school, we had 100 problems for every assignment. You can make as many problems as you want. If you decide you need to do another number 14, another one like that, just click similar question. Let's do that one. Okay. Such a good one. It is. Square root of 10 times square root of 20. So this is not number 15. This is number 14 again. So you can do as many as you need. Okay, to multiply square roots, we keep the square root. What are we going to have under here? 10 times 20 is 200. You could get up your Casio FX, whatever. I don't even know. 115 ES. Or do it the old-fashioned way. I'm going to do it the old-fashioned way. Pretend you have a TI-83, not a... What's the largest perfect square that divides into 200? It should be obvious. 100. Okay, so you have a square root of 100 times the square root of 2. And that's the step that a lot of times students want to say, oh, I don't need to show that. The square root of 100 becomes 10. And we have the square root of 2 attached to it. 10 times the square root of 2. And, I have an idea. Okay, let's not write in. Let's decide, okay, I'm tired. I don't want to do another one. I don't want to type that answer. And I'm going to go into number 15. Go back to my life. 10 square root of 2 is right. That's right. I can tell. But I want to try going there. It's going to warn you, hey, do you want to save that? Or look at this. If they ever ask you, do you want to save this attempt or save your best score? If you save this attempt, your green check for this problem is going to become a red X because you didn't type in an answer. The rule is simple. If you are ever asked, do you want to save this attempt or save your best score? What do you always check? Best score. Okay. But the answer was 10 square root of 2. If you don't doubt, you see, look, I can go back. Oh, no. I didn't save it. Okay. No, okay. Now, adding radical terms. Adding and subtracting radical terms. Okay. If you're adding square roots, you've got to have the same square root, the same number under the square root, and then you just add the numbers in front of the square root. Do not add the square root of 3 to the square root of 3 and get a square root of 6. You want to write that problem down? Well, first of all, I want to write the rule for it. Okay. And okay. adding and subtracting square roots. You have to make sure you have like radical terms. That means you have to have the same number under both of those square roots. So first of all, verify that you have the same numbers, I'll say the same number under the square root symbols. Well, that's a S-A-M-E, same
And you might
number.
wonder, well, what happens if we don't? Well, let's illustrate that.
Then you're going to have to simplify it so that you do have the same number.
Then
And then, once you've verified that, you add or subtract the coefficients. Switch back to that problem that we were looking at.
coefficients are what you call the numbers in front.
Just like the coefficient of a variable is the number in front of the variable, the coefficient of the radical or the numbers in front of the radical.
The 3.
So the 3 and the 7, those are the
A
square
lot of
roots.
times students would tell me,
I'll say.
I can do this problem without writing it down. Let's finish looking at Tim's sentences.
Add or subtract, whether it's addition or subtraction, you add or subtract the coefficients and keep the same radical part.
Say, square root.
Keep the same square root.
So you're not going to be adding the numbers under the square root, just the numbers in front of the square root.
Number 15, we had 3 square roots of 3 plus 7 square roots of 3. There it is.
Okay, now if this were, and it's not multiple choice, but back in the olden days when this Pearson first, I think it was Addison Wesley back then. Everything was multiple choice. So there'd be choices like 10 square root of 6, 10 square root of 3, 21 square root of 3, 21 square root of 9. Which one of those answers would be right?
You keep the same radical, the square root of 3, and then 3 plus 7. In this case, we're adding the coefficients. I agree with 10 square roots of 3. Make sure you have to add or subtract square roots. You make sure you have the same square roots on both terms. Then you keep that radical part. Add or subtract the coefficients. Any questions there?
10 square root of 3.
Okay.
What do y'all think? Easy or hard? Is this something that we need to write down to do?
I don't think we need to write that down. I think y'all can tell me the answer.
Do we have the same square root in both of these? So, 7 square root of y. Good. 7 square root of y. 2 square root of 5 plus, 2 square root of y plus 5 square root of y is 7 square root of y. They can't all be baddies. Huh.
Oh, here we're adding and subtracting.
Well, why don't you write that?
I'm going to.
Okay, you might be able to do it in your head. It looks confusing because of all those square roots. Sixes. How many times does the number 6 appear in this problem? 5? And then they write it again right under it. So when you glance at the screen, oh wow.
Okay, switch to my paper.
Okay.
Do I have the like square roots?
Mm-hmm.
Yes, so I'll write down the square root.
I think I've already heard the answers.
There.
You see the negative 6, that's
7 minus 6 is 1 plus 6 is, that's 7 square root of 6 that I heard.
7 square root of 6. I'll check it and
I want to do another one like that. So how do I get to the similar question? I'll close this little box out, say similar question, and, oh, okay, this one's a little bit better. There's not so many sixes, but there's still 3 of them. So could y'all tell me, oh wait, how funny. What's the answer going to be?
6 square root of 6.
Okay.
5 minus 2 is 3, plus 3 is 6 square root. So it seems like number 17, that programmer liked the number 6.
Number 18. Oh, Tim, you always leave me the hard ones.
The hard ones, please tell me.
I know, I'm just joking. But number 18. This one looks a little worse than the others, doesn't it? 3 square root of 125 minus 9 square root of 5.
Okay, hold on. Here's my thought process. Show the problem.
Oh.
Where's the problem? That's square root of 5.
But I just accidentally, my pen touched there. That's not a dot or anything, just ignore it, okay?
That's square root of 5. 5 is a prime number. There is no way you can simplify or change a square root of 5. So if we're going to get like square roots, what number had you better get over here underneath this first radical? A 5. So that's my thought process.
Let's use that.
125 divided by 5. What are we going to get there? 25? Is 25 a perfect square? That's what you want then, okay?
Now,
So,
follow my colors. I'm simplifying the 3 square root of 125 like this. I'm going to write down the black 3. Then, I'm simplifying the square root the same way we were simplifying square roots over here. Okay, like 63, 9 times 7. So, 25 times what? 5.
so circle that.
That square root of 125, he just replaced with the square root of 25 times 5.
I think circling it would make it messier.
Yeah.
So
So I'll carry down the black 3. This is a purple square root of 25. What am I going to write there? A purple 5, And now that square root of 25, that square root of 5, we can't simplify, which is sort of a good thing, because that's what we have right here. And this 3 times 5, what'd you say that's going to be? 15. So here's what problem number 18 is. It's 15 square root of 5 minus 9 square root of 5. Do we know how to do that? Yeah, this is the most basic problem-solving technique. If you know how to do one type of problem, and we know how to do it when they have the same numbers under the square root symbols, and you're confronted with something new, try to make it look like the old one. And I think that's what we've done. We now know how to do this. Am I going to do anything with these 5s here, other than just write down square root of 5? 15 minus 9, what am I going to put there? 6 square root of 5.
So if you don't have the same thing under the square root, try to simplify so that you do have the same number under the square root. And we have a final answer of 6 square roots of 5. 6 square root 5.
Tim, are your hands starting to hurt? Oh, wow.
Oh, the trials and tribulations of aging. Oh, I tell you.
Okay. Now,
But then I think about what the option is, and I'm like, oh yeah, I think I want to age.
okay, before I write down problem number 19, the instructions say rationalize the denominator.
Maybe you should state what rationalizing the denominator
That's what I'm going to do. So, to rationalize the denominator means to rewrite the fraction. If you have a denominator, that's the bottom of a fraction. So to rewrite the fraction so that it is not under a square root, and there is no square root in the denominator. What the heck am I saying? Whatever I'm saying it poorly, ain't I? Okay. Well, let's try to show what we mean by that. Problem number
19.
The square root of 11 over 2. Well, here we have a fraction under a square root. We don't want it written like that. We never want a fraction under a square root. So I'm going to start by writing it like this. I'm just going to break it up as 2 square roots. A square root of 11 over a square root of 2. So at least now we don't have a fraction under a square root.
But we do have a square root in the denominator.
So we need to somehow get rid of this square root in the bottom. And the way you do that goes back to this pink star rule that my brother stated. A square root times a square root is just whatever's under there. If you went up to someone, just another student, and said, hey, how do you rationalize a square root? What they're going to say is, you multiply, if they know how to do it. They multiply above and below by the square root in the bottom. Why are we doing that?
First of all, remember that for fractions, you can multiply above and below by anything as long as it's not 0 and still maintain equality. A number divided by itself is 1. The square root of 2 divided by the square root of 2 is 1. So we're just multiplying by 1. So whatever that square root is in the denominator, multiply above and below by it. Then you have to simplify using what you already know. You know how to multiply fractions. You multiply the numerators, then you multiply the denominators.
So how do we multiply square root of 11 times square root of 2? The square root of 22. No.
What about the square root of 2 times itself?
Just a 2. Look at how we've written the fraction. Instead of writing it with a fraction under the square root, we have it written with, it's just a fraction, and there is a square root symbol, but it's on top.
It's fine to have a square root on top of a fraction in a final answer. You can't have it in the bottom. You can't have a fraction under the square root in your final answer.
This is called rationalizing a denominator.
You cannot cancel something under a square root with something that is not under a square root.
Don't try to divide 22 by 2 and get 11.
If you're trying to do some sort of cancellation that you haven't seen us do in class, you're probably trying to cancel something you shouldn't be.
Yeah, like if you start trying to cancel 22 divided by 2 is 11. No.
And so with the fraction, always is going to be the bottom, like the denominator, that's going to be what you
Yes.
Okay.
Yes.
Perfectly said. Did y'all hear that? You multiply above and below by the square root that's in the bottom. Okay? Multiply above and below by the square root. Don't multiply above and below by 11, square root of 11. If you did that, you'd be rationalizing the numerator.
And in the calculator, this is the first time we've typed a fraction.
Okay.
Look right here. That first, once I clicked in the box, you'll notice the little toolbar appeared. I want a fraction. The first top button says fraction.
Even if it doesn't, you don't read it. You know, I never really look. It looks like a fraction, right?
We click the square root. What goes under this square root?
22.
Then click down in the denominator. What do you type there? Any questions there?
next one is the... Now, number 20, this is the last
No, I don't think so.
problem in the assignment. And so, it's got to have to be the hardest one. Yeah, Tim, I know it's the last
Yeah,
one.
you're right. I forgot the videos count as problems. You have to click on those videos even if you don't watch them. And hopefully you don't have to watch them. Hopefully what you've seen here today is enough. You can go home and get this assignment whipped out. But
Okay, I've written it down.
okay.
So this is the last problem, so it's got to be the hardest. Okay, well, here, it's already just written with a square root on the top and the bottom. So we did it wasn't like number 19 where there was a fraction under there. We go straight to this red step right here. Multiply above and below by the square root in the denominator. You know what? That's so important. I think I'm going to write that out. On number 20, multiply above and below by the square root in the bottom or in the denominator. I'll say denominator. What are those two words? Numerator and denominator. Remember, years ago a teacher said, remember, denominator starts with the D and the word down starts with the D. Okay, that's how you remember the denominators for the one and the bottom. So, having said that, I'm going to multiply above and below by what? The square root of 3. Don't multiply by the 5.
That'll just get you bigger numbers and you'll have more to reduce at the end. Just multiply by the square root.
Multiply by the square root in the bottom. So, talk me through what's that going to give me up on top. We would have just a 9. And what number's under the square root? 15. Now the bottom here is going to be tricky. Remember that pink star rule. The square root times the square root is just whatever's under it. So the square root of 3 times the square root of 3 is just 3. But we still have that 5. So we have a black 5 times 3. You see where I'm getting that 3? I'm multiplying. I'm going to do that circling with him. That might make it look messy. The square root of 3 times the square root of 3. I circled in blue. That gives me the blue 3. So we can still multiply the 9 and 3. Excuse me, the 5 and 3. 5 times 3 is 15.
Can we cancel this 15 up here with that 15 down here?
No.
You cannot cancel something under a square root with something that's not under a square root.
But what can be canceled?
9/15. That's 9 over 15. The things that are not under the square root. There's a common factor of what?
What could I divide both of those numbers by?
3. I agree.
So for this last problem,
9 divided by 3 gives me
3.
Square roots of 15. What have we got down here on the bottom? 15 divided by 3 gives me a 5.
I'm not sure if circling it made it look better. 3 square root of 15 all over 5. You see what I did there? Any questions? Should we type it in, Tim?
I guess I was just going to stall. I didn't want to let him go. Hey, y'all, okay, I clicked it, and now y'all tell me what I'm going to type first. The fraction bar, okay. And on top, what do we have? Okay, so 3 square root. And then what do I do? Click down on the bottom to get your 5. Is that what I wanted to type? Yes. And no next question. And notice we've done every question. No, we won't always do every homework problem, okay? We'll just do enough to get us started. But with
Or
this,
to get you going.
get you going, okay? But here for the first one,
We did everyone.
we had time to get everyone
Even though
done.
you might be thinking, well, wait a minute, why'd they do flip back? Some of these, I mean, like, did you notice a lot of these problems were just very, very similar? 6 through 11, we could have probably done without doing every one of those. But today, for the first one, we wanted to do every one of them. And we got them all done. Now go back to Pearson. At this point, you have 100 in the Pearson grade book. Okay? Now, it'll take a while. It's not, Canvas isn't just immediately syncing, but eventually, not eventually, pretty quickly, it'll show up in your Canvas grade book too. Don't
do that because that shows everyone.
I know, I did that the other day. Yeah, okay. But in your grades, Canvas grades, it'll show.
Wait, let me see.
Oh, not for 314.
Oh, wrong course. Let's see. We were just doing that one there. Let's see. This here. It's not
because you haven't synced it with
I
your,
didn't
yeah.
sync it.
Yeah, but there's your grades. You'll be able to click there and it'll show you the grade. But okay, but it isn't showing on mine, but it will eventually. Okay, it takes a while. Plus, I'm not really a student, and it knows it. Okay.
Now, Pearson, you can look at your Pearson grade book, and it treats you as a student.
Let me show.
Oh, what am I doing? I just did that.
Oh my
No.
God, Tim! Exit.
I did.
You see, that's right. We got to be very careful.
We have to
So some of y'all
blast
have already done this first assignment better than we did, okay?
Okay.
Get yourself a camera and start filming yourself and make videos and say, oh,
I think we got to stop recording.
yeah.